8.4 is the last section of notes in chapter 8 that we're doing. Actually, it's just the last section of notes. It's proportionality theorems. So again, going off of the idea of proportions. But in this case, it's for a singular triangle. We have three theorems that we're looking at: 8.6, 8.7, and 8.9. The triangle angle bisector theorem, okay, is 8.9. So 8.6 is triangle proportionality theorem. 8.7 is converse of the triangle proportionality theorem, going back to converse, inverse, contrapositive days. And then 8.9 is the bisector theorem. So looking at 8.6 to begin with, the theorem 8.6, it says if a line is parallel to one side of a triangle, if a line parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. Meaning, if I have this line TU and it is parallel to one side of the triangle, here we go, reading that directly from the theorem, and it intersects the other two sides of the triangle, which it does, then it divides the two sides proportionally. Meaning, I have RT, highlight that, over QT equal to RU over US. So if those were values, I could set up fractions and just follow that very nicely. And we'll see a little bit more in just a second. Similarly, 8.7 does what 8.6 does. It just lets you know that if the sides are proportional, then these two lines right here are parallel. So if you know that these pieces are proportional, RT over TQ is proportional to RU over US, then these two lines are going to be parallel. So we'll see how that looks in just a minute. So let's look at example 1A. It says in the diagram, QS is parallel to UT. Okay, so we know that. Well, if I look at those two theorems between the two, which one lets me know about the parallel lines first? 8.6. So I want to think about theorem 8.6 here. And 8.6 just tells me that if those two lines are parallel to each other, then these pieces that are formed by the line splitting the triangle are proportional. So this over this is going to be equal to this over this. Right, so just imagine drawing a line and making fractions out of the values here. Okay, the only difference is we're finding this value. It's missing RQ. So we want to set up these proportions. We want to say x over 9 is equal to 4 over 6. We're just going to do some cross multiplying here. So here, here, and then 6x is equal to 36. So dividing here, x equals 6, meaning this little piece right here equals 6. And if I were to simplify those things, if I had 6 over 9 and simplified that, that gives me 2/3. If I have 4 over 6 and simplify that, that gives me 2/3. So that's just another view if you're somebody who likes simplifying fractions, that 6 over 9 equals 2/3. Well, I don't know why I wrote 23, sorry. It's 2/3. And then 4 over 6 is also 2/3. So these are the same. That just, it gives you another view of how these parallel lines work. So I'll give you a second. I want you to look at B and find the length of YZ. So we're looking for this piece right here. We don't know it, so we'll call it X. Don't be confused with the naming of the triangle with the X. You can name it P or something if you would like. Actually, I'm just going to go ahead and do that so there's no confusion. We want to find P. So looking at this, we see that these two lines are parallel, and we're looking back at these theorems. The lines parallel go with 8.6. So we want to set up proportions again, and we want to say that, just again, draw fraction lines. And you have to kind of turn your head, but 44 over 35 is equal to 36 over P. So XW over WV is equal to XY over YZ. So do some cross multiplying here. Then we get 36 times 35 will give us 1260 equal to 44P. So divide here, so that means P equals 28.6. Again, just setting up those fractions according to the theorem. So these were all 8.6. This was 8.6 as well. I'm circling these so you can reflect back. Look at example 2 now. It says on the shoe rack shown, BA, so find BA, is 33 centimeters. CB is 27 centimeters. CD is 44 centimeters. And DE is 25 centimeters. So look at the outline of this triangle. Here it is. We want to know if the shelf, or explain why the shelf is not parallel to the floor. So the shelf is sitting on the floor, meaning the bottom of this triangle right here, this is the floor. So we want to know why this line and this line are not parallel. Well, if I look back at these theorems, 8.7 shows me a triangle that has all of the pieces equal to each other, the proportions equal to each other. And if they are, then that means these two are parallel. So that's the situation we've got going on here. So what they want to know is why on this triangle are those pieces not parallel to each other? Well, if they're not parallel to each other, that must mean that they're not proportional. So we should show that. So the same setup that we did on these, we're going to set piece over piece equal to piece over piece, but we have to show why they're not proportional to each other. And if things are not proportional, that means they don't have the same simplified ratio or cross product. So 27 over 33 equal to 44 over 25. So you have a couple of ways that you can do this. You can simplify. If you simplify them, 27 over 33 in your calculator simplifies to 9 over 11. And 44 over 25 is in simplest form. So when I simplify my fractions, I see that these are not the same. They're not the same. They're not the same fraction. So that's one way. That's one way to explain why the shelf is not parallel to the floor, because it does not have the same simplified, the proportions don't have the same simplified ratio. The cross product is the second way, and I'm just going to write CP for cross product. If I do cross product here, I do 27 times 25 equal to 33 times 44. That gives me 675 equal to 1452, which is not equal. 1452 is not the same value as 675. So again, the cross product is not equal. So those are two reasons why we know that this line, BD, is not parallel to the floor. AE, why the shoe rack is not parallel to the floor, because of these two pieces not being parallel to one another. And this is the floor. Okay, look at example 3. It says in the diagram, angles 1, 2, and 3 are all congruent, and they're marked as so. GF is 120 yards. We see that marked. Find GF right here. It's 120 yards. We see that following the rest of this, sorry, I lost my place. DE, find DE is right here, is 150 yards. And CD right here is 300 yards. Find the distance of HF. So it wants us to find this distance right here. Okay? So hopefully you see the outline of the triangle. It's kind of been split, right? We have this line down here. It's not really important, but we see this triangle that's been split. We know that these these horizontal lines are going to be parallel to one another, because we see right here that we've got a perpendicular angle. So these two, or three lines rather, are never going to cross. They're all perpendicular to one another, so that means they're not going to cross. They're parallel. So looking at that, we are wanting to find, again, HF, this green portion right here. And that means that we need to find this piece so we can add it to 120 yards, because whatever this piece is right here, if I add it to 120, it's going to give me that total. That's just how segment addition works, which we've looked at. But I can set up a proportion. So if I call this missing piece X, find it, and then add it to 120, it'll help me out. So I want to set up a proportion. Again, your triangle's upside down, but I know those pieces are parallel to each other, so I can go ahead and mark that on here, that all of these pieces are parallel to one another. They're not going to cross because they form a 90-degree angle with HF. So set up those pieces. 300 over 150 is equal to X over 120. You could have chose to go backwards. You could have said 150 over 300 equal to 120 over X. You could have done 120 over X equal to 150 over 300. Any of those would work. They're all good options. So we just want to cross multiply here. We get that 150X, I'm writing to the side here, is equal to 36,000. So divide, we get that X equals 240. Okay, and so X equals 240. So we know that this piece right here is 240. Write that in here. So 240 and 120 together, when I add those, so add those two things together, so this piece right here equals 360 yards. Okay. So lastly, we want to look at theorem 8.9, triangle angle bisector theorem. If a ray bisects an angle, and remember what bisect means, it means to be cut in half. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So looking at this triangle ABCD right here, to the left, or right, sorry, I don't know my directions. So ABC has this ray that split angle C. We know it was bisected because of these angle markings, so that means that this piece right here is going to be congruent to this piece right here, whatever they are. It doesn't matter. We just know that they're congruent to each other. So this theorem lets us know that this little piece over this little piece is proportional to this piece over this piece. Okay, so again, a lot of setting up pieces. So look at, I want us to do example 4B first. Okay, example 4B. It says find the value of the variable. Okay, so we see right here that we have a ray that has bisected these pieces. So we know that theorem 8.9 will hold here, 8.9. And these corresponding pieces are going to be proportional. So ST over TU is going to be equal to VS over VU. So 14 over X will be equal to 24 over 48. We can cross multiply here, find X, easy peasy. So we've got 24X equal to 672, divide, and X equals 28. So this piece right here equals 28. Okay. So the reason I wanted us to do that first is because A is a little bit different. You're given the total length of this side of the triangle, right? And we know that the theorem 8.9 holds here because we see this bisector. These pieces are congruent to each other. This piece right here is congruent to this piece right here. So we know that theorem 8.9 is going to hold here, and so we know that QR over RS is going to be equal to PQ over PS. but we don't know what QR is. We can write an expression for it though. Right, so the total piece, take away this RS, is going to be equal to QR. So I can just say that this is 15 minus X. And don't get all bent out of shape or anything. It's not going to make things any more difficult. So we do want to, again, set up a proportion. I'm going to change colors. So I have QR over RS, 15 minus X over X, equal to 7 over 13. I just want to cross multiply here. So we've got 7x equal to 13 times 15 minus x. So we want to distribute. And we've got, let's see, 7x equal to 195 minus 13x. So we want to combine like terms. Plus 13x, I'm going to have to move over here. So this is being carried over here. We've got 20x equal to 195. So divide, and x gives you 9.75. So x is 9.75. This is 9.75. So that means that this piece is 15 minus the 9.75. So 5.25. This piece that they asked for is 5.25.